This video is going to be part 2 of the Tektronix 465 2-channel analog oscilloscope repair, or more of an update if anything. If you remember in the first part of the video, I went ahead and checked and I found that this fuse to the high voltage supply was blown right open. So I went ahead and looked at everything else, of course, and found that this capacitor was no longer really a capacitor. It was actually pretty much testing in the picofarad. That's why I got a 47 electrolytic right now bodged in there. Yes, I will put appropriate capacitor once I get everything fixed on this scope, but right now I'm just kind of fixing stuff just to see if the scope's even worth repairing, not before I throw good money after bad. 2, I also found that someone was actually messing with the dryer. First, I originally thought that the driver itself was obviously shorted, which obviously would cause the fuse to blow, of course. And as you saw when I tested, put the multimeter resistance mode, it tested pretty much shorted. So I went ahead and disconnected the wire. Sure enough, it tested short, so I thought that the driver was actually short, so I took it completely out, and I noticed it has a lot of scratches on those nuts, so obviously someone was in there. So I took the driver transistor completely out and noticed that it actually tested as an NPN transistor and it wasn't shorted. And what happened was he had it miswired, and he also had the leads touching to the grounding. So that's of course why I tested like it was shorted. So I went ahead and wired it correctly, and no, it's not a PNP, it's an NPN, but he put in there was a PNP. And just to show you, here's the schematic, and this here is the transistor in question, and then here's the capacitor, the 47 microfarad capacitor I bodged in there, which goes to the high voltage transformer. Now unfortunately, the scope has a serious problem, and that's right in the multiplier. Usually I call them triplers, but here it says multiplier, so we're going to say multiplier. You know, and how I came across that conclusion was, of course, I went ahead before doing all that. I just assumed maybe 8-volt rail wasn't working, or it was probably something else. And I went ahead and tested all the low voltage rails and stuff like that. And all the low voltage rails tested dead. I mean, literally dead within spec. I'm talking like millivolts. Most of them like within 5-10 millivolts of each other. You know what it's supposed to be. And then I went ahead and did one test further, and I went ahead and tested for ripple and noise, of course, using the oscilloscope. And when I did it, I found that most of the rails were really good. I mean, they were like maybe 15-20 millivolts of ripple, and that was it. And most of them were even under that. So no problem with the low voltage supplies at all. I mean, they're all bang on spec. And not only that too, I also went further and I tested the filter caps on, which is on the other side. I can't see them from here. But I went ahead and, of course, looked at the bridge, found where the positive and negative was, and tested the capacity of those capacitors. Then low ESR, and pretty much, like, literally, like, maybe if 5% within tolerance. So there's nothing wrong with those filter caps at all. And obviously that shows, because when you do the ripple test, obviously there's barely no ripples. So those capacitors are in good shape. Nothing wrong with the capacitors there. Now, I did find, of course, I bodged another capacitor in there because that was leaking DC, so I replaced that there. I went ahead and, of course, tested the obvious suspects, which is sometimes these biasing transistors go bad and stuff. They are tested perfectly fine, good gain, everything. I went ahead and tested around there. Also tested for any open resistors, any open dials, stuff like that. Nothing wrong with it, you know what I mean? I couldn't literally find problem. I literally spent probably about 3 hours just going through the service manual and testing every component and stuff like that to see where the fault is. I even tested to see if the operation amplifiers were working and everything like that, and yeah, they are working. And I'm also getting, you know, of course, now oscillation. Now I wasn't getting the oscillation before, and I'll explain that. But yeah, I'm getting oscillation, no problem. So right now the high voltage power supply is working. I'm actually getting negative 2.4 kilovolts as it's supposed to be, but what I had to do to get that negative 2.4 kilovolts was actually lift that jumper right there, and then I went ahead and took a high voltage probe, and after a few seconds later, my negative 2.4 kilovolts reappeared. Now, one thing I do want to note, because I know there's going to be someone that's going to make this mistake, so I'm going to say it now. don't go ahead and measure the filament motor using your regular multimeter leads. If you do that, you will definitely get squared the crap out of, and you'll be looking to buy a new multimeter and stuff like that, because there's also negative 2.4 kilovolts on the filament as well. So be careful when you do that. And typically, if you're not used to or comfortable working with high voltage supplies, don't mess with it because it can be leaked. I had to get that out of the way. But either way it goes, I went ahead and did the next obvious thing because I know it's a common problem with these. And I lifted that jumper, which lifts the ground strap, which is in this case, because I didn't feel like removing this whole entire vertical assembly. And so the proper way to do would be remove this whole entire vertical assembly, and then once you do that, remove the shield which covers the high voltage transformer and the multiplier in there, and then take that ground strap and actually tape it up so it doesn't ground to anything, because right now if I turn the intensity up, it's gonna ground right over here. I got it turned down right now so it doesn't do it though. But we're going to front of the scope and I'll show you now exactly what it's doing. And let's just turn this up, assuming that it's still on. Yeah, there you go. And you can see there, we got a sweep. Yep, so Tripler's definitely bad on this one, without a doubt now. Exactly what went wrong with Tripler. Here, we're even going to go one further, and yeah, I got that. Come on. Go in. Yeah, now it wants to give me a hard time going in when it does. Okay, there you go. And if I go ahead and... Alright, we'll turn the intensity up a little bit. Hopefully it won't arc, because if it arcs, it does weird stuff. You can see there, here's our 1 kilohertz signal. And yeah, she is working. That means the vertical, horizontal amplifiers, even the trigger, works perfectly fine. And of course, I suspect that because all the voltage rails are within spec and there's no burnt components or anything, so I don't see why it wouldn't. But here goes, the rest of the scope works, fortunately. It's just unfortunately the tripler assembly itself is faulty. So in order to get this scope working pretty much, I would have to find a new tripler. And I looked on eBay to see, I don't know why I'm calling it tripler again, that's back in TV days, but let me go and do what it's doing right now. I'll show you what that noise is. You can see there where it's arcing over, and obviously high voltage likes to take the easiest path, and it's just jumping right over there. But we'll turn down the intensity so you don't have to hear that. But either way it goes though, the CRT itself is in good condition. That's a good thing, because I can turn the intensity way down, go at higher frequencies, and it's nice bright even without the multiplier and so forth. So that means this CRT has good emissions and stuff like that. And when I looked at the horizontal and all that, it's perfect. I mean, there's nothing wrong with the CRT itself. So I'm not sure what exactly I'm going to do with this. I'm not sure if I'm going to go ahead and take the risk and buy a new multiplier for this thing, but the problem is you can't buy a new multiplier new. If I could find a new old stock multiplier, I definitely would go ahead and put one in it, but you know, the problem is I would have to order it on eBay, which is a guy that's overseas. It's going to take about 6 weeks to get a new multiplier in for this thing. And then you don't know what condition that multiplier is in itself, because what they typically do is they pull these parts out of old scrap scopes that they get, because they get these SOAR Plus and stuff like that, and you don't know if that multiplier is bad, so you're waiting 6 weeks for it to find out that one's bad itself, because it is a common issue with these, and you just wasted 6 weeks and your money pretty much. And parts not cheap, they charge good amount for those parts and stuff. So this project probably gonna be put on a standstill until I can at least find one, or find another scope similar to in worse condition where I can find that it has a good multiplier in it, so I can yank it out and put it into this one. Now, either way it goes, because I'm doing a restoration on this thing, I was gonna go ahead and take the vertical amplifiers and everything completely out of this thing and stuff like that, and also clean the attenuators and stuff. So either way it goes, I'm going to have to get into that can to remove it anyway to put the new one in. So it's not a big deal, because I'm going to go and clean this up and everything anyway. You can see there, too, that this thing's low hour, because that's the fan there. And you can hear it's running. It's nice and quiet, dead silent. And like I said, all the main caps which normally go bad are still good. And I mean, the CRT has good brightness to it. So I'm not sure. I'm kind of scratching my head on it. I kind of want to fix it, but at the same time, too, I just don't want to spend the money on what they're charging for used. If it was new old stock, I definitely would, but not a used part that might fail anyway. So let me know what you guys think, pretty much.